Oh, good, you can see the top of my head. There's not much to look at there. All right, that's better. All right, so today what we're doing is we are going over projectile motion stuff. The big things that I heard through your learning log was that this stuff is really hard, but you guys feel like you are getting better. That with practice, you are learning a little bit more about it and you are getting mastery. But you still got lots of questions. Things that people said that help them is one, asking for help from others. Turns out that that's really useful. Rereading their notes, rewatching the videos, looking stuff up on Khan Academy, all that. People said that helped. People who feel like that makes sense to them now said that it was really, really hard, and then all of a sudden it made sense. That it wasn't a gradual thing. It was a, I'm confused, I'm confused, I'm confused. Oh, I got it. It looks obvious now. And that's what a lot of physics is like. And the last thing that I heard a lot was that people wanted more problems. Easier problems that they could use to work up to the harder problems. All right, so that's what today is about. Those easier problems to help you step up to the harder problems. I'm going to give you a problem. You're going to hit pause. You're going to do the problem with your group. You're going to hit play. You're going to watch how I do it. You're going to hit pause. You're going to change your work if necessary. You're going to hit play. Next problem. So on. We have 11 problems today, and we're going to get through that as quickly as possible. All right, problem number 1. You have a skateboarder jumping at an angle of 15 degrees with an initial speed of 4 meters per second. Find the y component and x component. Hit pause. You just hit play. All right, so my very, very blurry picture here shows you sort of kind of what's going on. I got my triangle right here. And right here, I have 4 meters per second and 15 degrees and my x and y components. All right, now to get those, I'm going to use v naught sine theta and v naught cosine theta to get my y and x components, which ends up being positive because it's up 1.04 meters per second and positive 3.86 meters per second. The positive because it's up, the positive because it's forward. All right, next. A ball is kicked such that its initial velocity has an x component of positive 5 meters per second, so forward, and a y component of positive 15 meters per second, so up. What is the net initial velocity? Hit pause. You hit play. All right, here's my work for this one. Again, I got my lovely triangle, except this time I'm doing it the other way. I have my y component and my x component already. I do not know theta. I do not know my v net. So I'm going to look at tangent. I know that tangent, theta, will give me opposite, 15, over adjacent, 5. Okay, so 3. That means that inverse tangent of 15 over 5, 3, will give me theta. And that gives me my final angle of 71.56 degrees. All right, and then I'm just going to use Pythagorean theorem here. 15 squared plus 5 squared equals v net squared, which gives me an answer of... Oh, I didn't put it on this one. I'm sorry. This answer is wrong. This 15.21. Yes. 15.81. Sorry. That's wrong. It's really positive or negative 15.81. You do not know at this point whether it is positive or negative. So let's think about it. Let's look at the picture. It doesn't matter. Pause. You just hit play again. All right, so why doesn't it matter? Because I'm giving you an angle. Positive and negative just tells you direction. You don't need a direction if you have 71.56 degrees. All right, did I trick you? I bet I tricked you. Moving on. Cat jumps with an initial velocity of 11 meters per second at an angle of 63 degrees. How long is the cat in the air? Hit pause. You hit play. All right, so here's my really blurry picture. But I got the same deal. I got my 11 meters per second here. I got my 63 degrees. I broke it up into my x and y components, which gave me positive 4.99 meters per second and positive 9.80 meters per second. I'm then going over here and I'm going to make a list. I am asked to solve for time. Well, I know my initial velocity in the y direction. It's positive 9.8. I know my final velocity in the y direction. It's negative 9.8. Whatever goes up must come down at the exact same speed, opposite velocities. I also know the acceleration in the y direction is negative g, or negative 10 meters per second squared. So I'm going to use this lovely equation here, Vf equals V naught plus AT, math, and I get T air equals positive 1.96 seconds. All right, same deal. What's the maximum height of the cat's jump? Hit pause. You hit play. All right. So I already know what T air is from the last problem, which means that I can find T half. It's going to be half of that. And at T half, I'm going to have a V final of 0. Same V initial. Same acceleration. I'm going to say that my initial position is 0, ground level. So my final position is going to be a question mark. I then solve for it using this lovely equation here. I get my answer, positive 4.80 meters. We're going to use this equation a lot. All right, same deal. How far forward does the cat jump? Hit pause. You hit play. All right, well, I know T air already, and I know the initial velocity in the x direction from a previous problem. So I'm going to make my list. I'm going to use this equation here, and I get my final answer, positive 9.78 meters. Yay! My timer is telling me that I'm already at 7 minutes, so I'm going to pick up the pace a little bit. All right, ball rolls off a horizontal table. Table is 1.2 meters high. It lands 0.45 meters away from the base of the table. How long did it take to hit the ground? Well, I know that my initial velocity in the y direction is 0. Therefore, I know that my final position is going to be 0, and my initial position is positive 1.2, blah, 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 blah. I can solve for time. It's positive or negative 0.49 seconds, which logic to tell me that negative time doesn't make any sense. Therefore, it must be the positive 0.49 seconds. All right, what's the x component of the initial velocity? Lol, all of it, right? Oh, except problem didn't tell me. I'm going to have to work backwards. Now, if the problem had told me what my initial velocity was, since it's rolling off table horizontally, all of that net velocity is my x velocity. But they don't tell me that. So I'm going to have to use the fact that I know the range and the T air. So I can solve for V naught in the x direction, which is constant in this case. All right, what's the initial velocity? We just talked about that. All of it. If there's a 0 in the y direction and 0.92 meters per second in the x direction, that gives me a net velocity of 0.92 meters per second at a theta of 0 degrees. All right, I jump off a cliff. I must be crazy. 4 meters per second at 15 degrees. Oh, look, just like problem 1. And the cliff is 7 meters high. How long does it take for me to hit the water? Well, first I break my stuff into x and y components, just like problem 1. Then I am going to look at just the y direction. I know my initial y position is 7. I know my final is going to be 0. I know my acceleration. I know my initial velocity. I'm going to solve for time, and then I'm going to say nope. Because look at this. This is a quadratic. And I really hate the quadratic formula. So I'm not going to do it. Instead, I'm going to cheat. I'm going to go over here. I'm going to solve for v final. I don't need v final. I'm going to do it anyway. So I'm going to plug everything in. I'm going to solve for v final. I get negative 6.01. Negative because down. I need to choose negative. And then I plug it in down here. V final equals V initial plus AT. And I get my T air. 0.705 seconds. I have only seconds remaining. All right. How far away from the base of the cliff do I land? Bam! V naught times time gives me range. And finally, what is my velocity when I hit the water? Well, I already know my velocity in the y direction and x direction from previous problems. So I'm just going to trig it like I did in a previous problem. Weird thing, though, is I'm going to get a theta that's negative. That means it's below the horizontal, which if I look at my picture, makes sense. Ta-da! At this point, you should have done all these problems, and they should sort of kind of even make sense to you a little bit. Good job.